Okay, so whatever I was talking about, that we have different software and we should know what are the advantages and disadvantages of each and every software. So we'll try to have the optimum timing or the optimum time to finish our job. Okay, so as we said last week, we have 5 weeks for specialization training, construction in Oman, which we have finished last week, structural analysis and design, that's the topic of this week, and then we are going to take some basics of advanced design and structures, basics of highway design, concrete and construction sites, and then lastly we are going to end up with the project management. Now, when it comes to this week agenda, we are going to take um, four things as well. These are analysis of elements, design of elements, design for gravity loads or the two-story building, and then finally design for multi-story, where we are going to design for gravity and lateral loads. Okay. Now, when it comes to analysis, as I told you, a lot of consultants here in Oman, they are using Excel for the design, especially for typical elements like isolated foundation or slabs. So we can do the analysis in what you call in small software, and then carry out the design in the Excel, or we can design and do the analysis using software as well. That's going to be uh, the topic of the second day. Okay, but design of elements will be separate elements only. Okay, and then we're going to carry a full building, and we should know when to go for gravity only and when to go for gravity and lateral loads. Okay, so we are going to go for analysis of elements. Now, in terms of analysis of elements, today's lecture is going to be divided into three sessions, where we are going to talk about around softwares, seven software packages, seven maybe. Okay, so we are going to talk about in the first session, which is related to beams. We are going to talk about SkyCiv, uh, robot structural analysis. But here we are not going to use the what you call the regular modeling of robot structural analysis. We are going to use the wizard of robot structural analysis, so we are going to save time. The intention of doing this analysis of structural elements is to use the minimum time to get the forces. Okay. And then PolyBeam, a continuous beam analyzer. So now this is the first one, SkyCiv. Second is robot structural analysis. PolyBeam, third software we're going to use, continuous beam analyzer. Fourth one, 2D frame analysis. And then number 6 is BeamAx. In the frame, once again, SkyCiv, robot structural analysis, 2D frame analysis, and then Procon, so number 7. And then we are going to have for the trusses, SkyCiv, robot structural analysis, trusses, that's number 8, and then 2D frame analysis. So today we are going to use around 8 software. I'm not going to spend a lot of time in explaining the software. What I'm going to do, I'm going to highlight you what are the things that this software can do with one example only. Most of these software can be downloaded for free. Some of them are having students accounts, some of them you can download them as trial. Okay. Like for example, when it comes to SkyCiv, you can have free student account, but it's limited. You can upgrade your account for around 4 riyals for a student account, full student account. Robot structural analysis, 4 riyals per month. Robot structural analysis, you can download an educational version for 3 years, which is renewed as well. PolyBeam is a freeware, you can download it for free. Continuous beam analyzer as well is a free software. 2D frame analysis, you can download the trial. It's not for free. And then BeamAx, once again, it's for free. Brocon, you can download the trial as well. Trusses Plus is a freeware. So most of them are either free or they have educational license. Few of them are you can download them for trial and try the software. Okay, so I'll try later on. I'll try to post one post in the Teams for you where you can download these software. Now SkyCiv can be downloaded or you can use the website as well. It's an online platform software analysis. Okay, so we are going to do the beam analysis in these seven. First we'll have question and answer, basic question and answer, and then we'll go for the frames, and then once again question and answer, followed by a very short break, and then we are going to go for the trusses. Now going for the SkyCiv. Okay, going for the first one, that is SkyCiv. This is how SkyCiv looks like. Okay, this is how SkyCiv looks like. Let me just okay. So this is SkyCiv. You can enter to it either from the software. You can download the software in your computer, PC or laptop, or you can go to SkyCiv as well. Okay, where you can go for this particular website and you can do everything in the website itself. Okay, anyhow, since it's downloaded, we are going to go and use the the software in the laptop. The software is having different modules. We have Beam Structural 3D, Structural Builder, Section Builder. We have Shaft, we have 2D trusses, frames, member design, concrete design, connection design, foundation design, and load generator. For me, so one of the biggest advantages of SkyCiv that it's really good when it comes to students. Most of the students, those who didn't deal with SkyCiv, they have lost a lot of their educational time in learning and understanding certain things, and I'll show you why and what I mean by that. Now, another thing, this software is an online based. So whether you are using it from a PC or you are using it from a laptop, whether the laptop is strong, it's weak, whether you are using it from the phone, it will work for you because it's simply an online platform, which is different from the other software. All the other software are computer based. This is an online based, so you can use it whether it's computer or in in a phone as well. Okay, so they have different modules. So this is the beam structural 3D where we can do the frame as well. Section builder where we can get the basic properties like I, center of gravity, and other things. And they have other modules like shaft or trusses, member design for steel, concrete design for concrete, and automatic. Our main desire is to go for beams. Okay, so let's go and just check what this software can do for me. Now going for the launch button. Okay, so a window will appear for me saying that I need to input different things. First is add a beam, so we can add a beam. It will ask you to input how many meters are there inside this particular beam. Okay, so for example, let's say I have 12 meters, so I have added, and it will show you that I have a beam which is starting from 0 going to 12, and then adding a support. For example, let's say that they have fixed support on the left end, so I'll choose fixed support on the left end and then add it, so automatically added. Now you can see here I'm saving a lot of time compared even to using software like robot structural analysis or ETABS or STAT or whatsoever. Okay. So that's why the good engineer, as I told you, is a person who will know that if I want to finish this job, I have these options, and in these options, this is going to be the best optimum option for me. Okay, so let's add another support. For example, I want a pin support, which is intermediate, for example, at a distance of 4 meters. So I have added it at 4 meter. A support came for me, and then I can have another support, for example, at 7.2. So 7.2, another support, and then finally, let's say for example, I'm having another support, which is a ruler support, for example, at the right end. So I have different types of support: fixed, pinned, intermediate pins, and then we have a roller support. Now we have finished from the adding the beam, adding the support, going for adding point load if you want. So going for add point load, it will ask you, is it downward beam, downward load, upward, or a downward with an angle. So let's try first the downward. Let's say that number of loads is 1. Load position, where do you want it in the beam? So for example, I want it at a distance of 8 meter, and I want the magnitude to be 25, for example. So I have added it. You will see at 8 meter this particular load came for me, and I want to add another point load, which is with an angle. Let's say that the load position is available at 5 meter. Load magnitude is let's say 30, and then the degree I want it to be, for example, 30 degrees, and then I add it. Okay, now what you can see, we have done different loading, different point loads, different supports. Now one of the things that you might consider here, to note that normally we don't have, in reality we don't have an inclined loading, uh, unless it's a special case. Okay, now other than that, you can go for adding a moment, and once again it's clockwise and anti-clockwise. Let's just try now. So 5 meter, and then moment magnitude, for example, 12. So we have added, let's keep it here, for example, at 10. Okay, so we have a moment here, for example, this is a counterclockwise. I want to change it and keep it as a clockwise. You can go from here, you can see everything we have done is available here. So we can click on edit, and then I don't want it to be counterclockwise, I want it to be clockwise. Click here and then save. You will see that this has been shifted to be 12. Anything you want to modify, you can modify from here. Okay. Like let's say I want an overhanging part here, I want to increase the length of this beam to be 15 meters. So what I need to do, I'll go for the beam, the end position is 12, so I'll go here, click on changing from 12 to 15. Now you will see that the total length of the beam is 15, and then we have an overhanging part of 3 meters, or we can have it, for example, as 13, and then we have 1 meter of an overhang. Okay, we can go for adding a distributed loading as well. It says for you, do you want it to be from 0 to 13? For example, let's say I want it to be from 0 to 4 only in the first span, and I want the magnitude to be for example 5. Okay, the second one is 5. This is beginning, and this is the end. So if it's a uniformly distributed loading, the start and end is going to be the same. If it's uniformly variable, it's not going to be the same. It starts with 0 or a certain value, and then it increase or decrease to another value. That's in case of a UVL. So we're adding it. So you can see that we have a distributed load of 5 now. Going for adding distributed load, but we want it to be a UVL. So let's say that this is going to be from 4 going to the last portion, that's 13. The magnitude will start from 0 going, for example, to 10. Now you can see what we have now. We have a triangle load, like representing for example a soil pressure, or representing a water pressure as well. Okay, so we have done whatever we require. There is additional hinge if you Yeah, let's just what you call stop at whatever we have done. We have modeled a beam with different supports, with different loading, just for the sake of trial. Okay. Now there is an option for me to go and solve, and you can see in the first one it's showing you the reactions. So how much is the reaction? And you can know that here in this case, this is a fixed support, so you're having vertical, horizontal, and then the moment. Two reactions, and then one reaction. So they are giving you all the reactions. This is the shear force diagram. Okay. And this is going to be your bending moment diagram, whether you want it to be downside or you want it to be the regular way. So going up because of the fixed support, down and then up. First support goes up and then down, and then because of the moment here it goes down and then once again up the support, and then in the free what you call in the free overhang, finally it ends up with zero. Now if you can see, the software is very easy in terms of modeling. I can return back, for example, changing the value of moment of anything that I want to change. I can change it from here. So for example, I want to change the length of the beam. Once again, I can go and change. If I want to change, for example, the, the moment, let's go and change the moment here. I want it to be counterclockwise and is having a value of 15, for example, and that's it. So now it became to be 15. Once again, go and solve, where the software will be solving for you, taking into account now it's counterclockwise and then 15. Okay. Now you'll see that it's going up instead of going down because of the different direction of bending moment, or the opposite direction of bending moment. Anyhow, one of the good things that he was talking about as well, that this software is one of the few softwares, if it's not the only one, that is showing you the hand calculation. So, uh, so for example, the hand calculation. So it will show you how would you calculate the hand calculation, like how did you study in the college. Okay, how to convert from triangle to a point load, multiplying into one third and whatsoever, whether it's statically indeterminate or not. If it's statically indeterminate, of course you need to do moment distribution method, and you can see now this software is carrying out calculating for you manually the moment distribution method. A lot of students in their project, they spend a lot of time in doing the moment distribution method manually or using an Excel, which does not show them the full thing. But anyhow, if you go and see here, you can see they are telling you which cases are there, which position, stiffness calculation, and then you can see the coefficients here, and then fixed end moments calculation using whatever you have studied, W square or 12 and the other things. Okay. And you can see for segment 1, segment 2, and it goes on, different segments are there. Okay. And finally this is a moment distribution, where it shows you uh, the distribution factors, the coefficient of distribution, and everything till you end up having your values of bending moment. Okay. So after that, that's why if you remember, this is a fixed support, that's why we are having a value. This is a free end, that's why we are having a zero. And then after that you can compute the reaction, like whatever you have studied in the college, from after getting the bending moment. So this is the same way that you have studied. Okay, it will show you everything, just exactly similar to the way have you have studied. Okay, and then shear force as well. So how did you do the shear force? Using the section method, it's showing you. No other software is showing you in this way how details is the calculation. Okay. So for me, for example, this software is very good when it comes to students in verifying his his answers, for his assignments, for his quality work. A software is very simple. You can change, you can undo, you can redo a lot of things. It will not take you time to model a complicated element with complicated loading compared to the other software. The results is the result platform is very easy. So once again, instead of using other software, this might be the ideal software for you. Again, once again, you can go and download the PDF. You can go and download the PDF. It might take some time depending on the depending on the depending on the net as well. Okay. Anyhow, just try this. Okay, so this is a manual calculation that you have seen. Oh, this is a hand calculation for everything ready for me. No need to calculate using my hand. Okay, so this is one of the advantages of SkyCiv. Okay. Going for the second software, so we'll not spend a lot of time. Second software for us was robot structural analysis. A lot of you have used robot structural analysis, yet most of you don't know that there is a wizard which can do a lot of things in the minimum time for me. Okay, I don't want to spend a lot of time in modeling a beam. Okay, which will take me a lot of time, a lot of details. So let's just highlight an example of using the wizard or the generator from robot structural analysis. So going here for shell design or any other one, you can see here this is saying for your library structure. Going for a library structure, so we have plates and shell like water tanks, different shape of water tanks, different shapes of slabs with opening, without openings, load bearing and other things. For me, I want to go for library of typical structure, beams, frames, trusses, and you can see these are ready 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 elements for you. Okay, so we can go for the beam, for example. It will ask you how many spans you want. For example, I want 5 spans. What's the span length between one support to another support? So for example, you want to have it as 7. You can choose which section you want, like for example, whether it's a steel section, whether it's a concrete section, you can choose from here. Anyhow, let us keep it the default now for the sake of calculation and saving time. Insert as an object. Okay, apply, and then okay. Now what you can see, how many spans we have: 1, 2, 3, 4, and 5. The distances between each one span and the other one. You can go for tools, dimension here to here, and then it says so the dimension is 7 meter. Okay. Now you might see that there are different support conditions here. You can change from here. So for example, keeping it as pen, 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 and then keeping this one. For example, if you don't want it, you can delete it. Going here. Okay. So different elements. Now one of the other things that you need to know, changing the span here is a bit not an easy task, but there are certain things which will help you. Like for example, there is a plugin done by the developers here. Like for example, this is a plugin. Okay, I'll try to upload this for you as well, where it will change the the bar length for you. Okay, so this bar length, for example, is having a dimension or a length of 7 meter, and I don't want it to be 7 meter. Now when I click on it, it automatically says for you the number of bars. So the number of bar is number 5. This is what we have seen here. So I want now the number of bar is going to be, for example, um, 3 meter. I'm going to change from 7 meter to 3 meter, and then I click on change bar length, where you can see that this has been changed automatically. And then the tools, in order to check whether it's 3 meters or not, you can see now it's 3 meters. Okay, so most of you, even you have used robot structural analysis, most of you didn't know that there is a library which will generate for me the shapes, so without modeling, without taking a lot of time. And there is a plugin to change the length, whether it's a beam or a column or whatsoever. Okay, instead of modeling the whole thing from the beginning. After that, you can go and add the loading if you want. So we need to identify the load. Okay. And then, for example, putting a dead load, let's say, putting a dead load of x's and the horizontal according to the robot structural analysis. Y is horizontal, the other side, the third direction. Z is the vertical. So if we need to upload, we should go for Z. Positive is up, negative is down. So we need to go and have it down. For example, -5. Okay. And then add, and you can choose all the bars. Click here, so apply all the bars directly, and then apply, and you can see that this is coming for you. You can click, you can remove the self weight as well if you want. You can go from load table, removing the self weight. Okay, if you want, for example, removing this one, bar force. So we have this one. Now I want to go and calculate. Okay. This is related to the parameters of the material, so we can choose the material type, and this will be removed, so it's not an issue. If you are seeing a blue color letter, then it's a meaning, it's a warning only. If it's a red one, then it's an error. And we can go to results diagram for bars, for example, and we can see the my, which is representing the bending moment. If you are seeing it in this way, it means it's not normalized. You need to click on normalize. So this is the bending moment for this particular beam, where fixed end is here, and this is the free end. This is going to be your shear force. Okay, and you can see the values from parameters, and then you can click on labels, right, and you can see the values for each and every point. If you want only the bending moment, then remove the FZ, which is the shear force. So this is the bending moment. Okay. The maximum support is -22.5, the maximum span is 10.5. If you want the shear force, then this is going to be your shear force, where the maximum negative is 17.88, the maximum positive is 17.6. Okay, so for those who didn't know this one, this will be a very useful tool. Instead of going and modeling one by one, drawing the what you call the excesses, and then finding the dimension whatsoever, you can use the library which is ready from robot structural analysis. Okay, so once again, the SkyCiv, it's having its own advantage. Robot structural analysis, it's having its own advantage when it comes to the wizard. We can go for PolyBeam now. This is PolyBeam, and you can see in this one, it's very basic. It looks very basic. What we need to do, we have here the supports and hinges. This is a point load. This is a distributed load. and then this is the beam property, so it does not have a lot of options. For example, adding for example a moment, or adding uh, let's say uh, different types of loads, like for example a point load with an angle. You cannot make it here. So this is for certain things, but it's very simple. Like for example, we need to start here by saying that here my beam starts at 0 and then it ends up at 12. Okay, and then click on enter, so this will continue. Now for the supports, you want it only as FZ and M, okay, because in most of the structure in reality we don't have a horizontal reaction, either a vertical or a fixed, okay, which is representing Fz and M. So for example, let's say point X at a distance of 0, for example. Okay, I want it to be Fz only. So you can see that this is coming to be a ruler, okay, or this is coming to be a hinge, sorry. Because once again we say horizontal normally is not happening in reality. Okay, in terms of typical structures like buildings and so on, they are available in bridges and other structures. Okay, if I click on M as well, means it will change from being only vertical support to a moment support as well. So it will change to be as a fixed support. For example, I want another one at 3 meter. This is going to be a pin support. I want another one at 5 meters. So this is going to be, for example, a support I can change from here, giving it, for example, at 10. And then the last one, for example, I want it to be 12. Here it's fixed as well. Okay. And then you can input the load. So for example, if you want a point load, I want the point load at a distance of 5 meters. All the distances are measured from the left end. I want it to be 50 kilonewton. If you want to have moment is available here. Okay. So let us say that I want the moment as well at 5 meters. So you can see that I have the loading coming for me, which is a point load, and then the moment. So moment is there, but we don't have a point load with an angle, for example. I want to have a distributed load starting from 0, going for 12. Q1 once again is the starting intensity, and then Q2 is ending intensity. If you have a UDL, both of them are having the same value, okay, which is the value of the UDL. If you have a UVL, then uh, it goes 1 to be less and 1 to be more. So for example, 5 and 5, you can see a UDL coming here from 5, starting with 5 and then ending up with 5. And you can see directly the software is giving you the reactions. So the moment, the reaction here, the reaction in these two supports, and then the fixed support as well. Okay. If I want the shear force, I can go and click from here. So this is my shear force. Okay. So going down, because of the negative reaction, you can see the negative reaction here. The negative reaction means that these two reactions, because of the point load and depending on the moment which is occurring here, these are too huge. Okay, so these are more than the load applied. Okay, so in this case, what we need to do, we need to provide an opposite direction reaction. Okay, so this is the shear force. This is the bending moment. Okay, and this is going to be your displacement. Okay, and you can see the displacement in the fixed is always 0. When it comes to support as well, the deflection is 0 as well. Okay, there is an angle, but the deflection is 0. So this is PolyBeam as well. It's a very simple software which can do for you the beam analysis in no time, saving you a lot of time from going to other options uh, which are available over there. Okay. There is an option as well to design if you want. So it's going to give you the design. For example, design of steel, but this is only according to Euro codes. Okay, so it's giving you whether this section is safe or not. You can go and change the section. You can go and change the steel grade, the partial factor of safeties, and the other things. Okay, whether it's a concrete design, you need to change the material and then work it out from the beginning. Anyhow, we are not going to go for the design since it's not our topic. This is only just to highlight for you the thing. And you can see, for example, here for those who have studied the steel, you can see that the FY have reduced here, have been reduced here, due to the thickness being more than the value of the thickness of the web or the flange. Okay. Anyhow, so this is PolyBeam. Going for the last option, I think. Now still we have continuous beam analyzer, 2D frame analysis, and then BeamAx. So continuous beam analyzer. This is continuous beam analyzer. Once again, it's a very simple software. Going for a new, it will ask you what's the total length of the support. So for example, the total length is 12 meter. Number of span, I want the number of span is going to be 3, for example. Modulus of elasticity, moment of inertia, you can input it as well. Do you want it to be fixed pin, and it goes on. So for example, let's keep it as fixed. Okay, so it's showing you that we have fixed, but the inter support, the what you call it, the internal supports are kept to be pinned always. We cannot have fixed in the internal. We can choose the beam. We can go for edit and then adding a load. Okay, so for example, I can add a point load. So the intensity is 5, and you can move it wherever you want. You can see up. This is in the span of 4 meter, which is this one. So I can put it in anywhere I want. Let's say here, for example. Okay, so this is happening here. I want to add a UVL. So you want it, for example, at 5, and then this is going to be 10. So you can see now how it's visualized in span number 1. So we are adding it. So this is how it's coming for you. Okay, going for, after we finish, we can go and click on beam number 2. Once again, edit. Okay, span length you can edit from here. Span length, for example, keeping it at 5. So we have 4, 5, and 4. Okay, we can go and add load, and let's say, for example, I want UV regular one. Here is 5, and then here is 5. You can change the location as well. That is not going to be full UDL, it can be a partial UDL. Okay, and then we can go for this one here. We can try partial UDL. Okay. Partial UDL, let's say 15, for example. I want it not start from the beginning. Let's say start from 0.5, and then it will end up at 3.5, for example. Okay, so you can see now it's a partial UDL. After you finish, you click on compute and then analyze. You can see that this is the bending moment of the beam. Okay, different things are here. So bending moment, shear force are there. So this is my shear force. This is my deflection. So how the deflection according to the EI value, and this is the slope as well. Okay, so different things are there. Very simple software. It will not take you time to do the calculation instead of doing moment distribution method, for example, manual, uh, for checking your classwork or your design as well, or your basic analysis. You can do this particular, or you can use this particular software. Okay. Going for 2D frame analysis. So going for 2D frame analysis. Now this is how the software of 2D frame analysis. I think you can get a trial version of this particular software. Okay. So what we can do, we can go for file from here, and then new from template. Okay. So in the template they have ready template for frame, truss or beam. Let's say that for example I want to go for beam. Okay. So I want it to be steel, no, for example I want it to be concrete. So here is steel, I can go for import from library, which code you want to use or which material. So I want for example to use BS, Euro is there, Indian is there, ACI, American, almost everything is there. So BS concrete. For example I want to use um, for example 35. Okay. Now or I want to use 30. Now you can see here we have C25 30, we have C30 37. So which one to be used? You should know that this is the typical way of writing the grades of concrete. C is representing the concrete, 25 is representing the cylinder crushing strength or compressive strength, and then 30, the first one is representing the cylinder, second one is representing the cube. Now when it comes to the BS code is using the cube. So if anybody asks you BS is using which method, you should know that BS is using the cube. ACI American code is using cylinder. Your codes is using cylinder. So we have the Indian and the BS are using the cube method. Okay, so we can go for 30. Okay, insert. So now you can see 25 to 30, everything is mentioned here for you. You can modify if you require. Anyhow, we don't need to modify which section. So I can go for the section. Is it rectangle, box, angle, whatsoever. So I can go for rectangle. For example, putting the width to be 200, putting the height to be 400. It will calculate everything for me. Click on OK. So now we have it as, you can change the name. So 200, 400. So it's 200 into 400. How many spans? For example, I want it to be 3 spans. Typical length of the span is 5 meter. Let's keep it to be 3 meter, and we can have the option of adding a vertical load directly. Okay, so we can put for example -5, and we can see here that the loading is coming -5 directly. So this is going to be the loading, which is saying for you that this is going to be the span number 1, 200 to 400, span number 2, 200 to 400, and it goes on. Okay. Anyhow, you can go and run the, the analysis. Other things that you can do as well. Okay. Elements. You can assign. Okay. You can assign a section, assign a material as well. You can change the things, the support from here, for example. So if I want it to be fixed, I can go and add a fixed support, change it here, keeping it as fixed. So this is fixed. Okay. So you have different support conditions are there. You have the grade, you have different loading as well. So for example, if you want to add a vertical point load, so we can go for point load, enter a point load. So for example, -50, -50, wherever you want to keep it, you can go and keep it. Okay, this is a joint only. Okay. So for example, we can keep it 50 here, or you can keep it in the span as well, keeping a loading in the span. So different options are there. Finally, you can go and run the analysis. So after you run the analysis, this is going to be your deform sheet or the deflection. This is going to be your reaction. Okay. This is going to be your axial force. Now since we don't deal with compression and tension, this is a flexural member. We need to understand that there are axial members and there are flexural members. لما يكون عندي when we have the loading is perpendicular, the loading is perpendicular to the cross section, this is the flexural, the element is bending. When do we have the the element and the loading are acting in the same uh, the element major axis and the loading are occurring in the same line, then this is going to be considered axial loading. A good example of axial member or axial loading is column. You can see the load for the column is coming on the same major line. So this is my column. It has a major axis and it has a minor axis. So the load is coming to be on the same line of the major axis. For example, when it comes to the beam, this is my major axis and that is going to be my minor axis. The load is acting perpendicular to the major axis. Okay. So beam slabs are flexural. That's why they are designed for bending. We design them for bending. When it comes to column, mainly we design it for axial loading or forces. Okay. So shear force diagram, and then we have bending moment diagram because this was a fixed support and this is ending to zero. Okay. So this is 2D frame analysis. Another easy software where more details are there a little bit when it comes to choosing the grade of concrete, choosing the section itself. Okay, going for the last option, which is BeamAx. Okay. Going for BeamAx, let me just close those that we have finished from. Okay, so we have SkyCiv we have finished from, and then the last one is okay, this is BeamAx. So in BeamAx, simple simple software as well. You need to go for file, new, or you can click here. Okay, so new, enter the beam length. So once again, for example, beam length is 10. So this is my beam. Now I want, for example, this is a fixed support. What you call a hinge and a roller. So for example, I want a fixed support. Left end, I want it to be on the left end. Okay. Okay, and then I want to have pin support. At which distance? So for example, I want it to be at let's say 6 meters, and then I want to have another pin support at 10 meters. Okay, so we have fixed pin and then pin, and then I want to have point load. So load position in where you are going to put it. So for example, I want it to be at 5 meters. Load value is going to be, for example, 12. So at 5 meter, this is coming, and this is going to be your bending moment value. I want to add a UDL. Okay. So load position is 0. It will start at 0. Load length, it will end up where? It will end up, for example, at 10 meter for me. I want it to be from 0 to 10, and the load value is, for example, 20. So you can see from the beginning till the end with the value of 20. You can see that this is going to be your bending moment diagram. This is going to be, from here you can see that this is your shear force. Okay. So we have bending moment. Q is for shear force, bending moment, and this is going to be representing for you your what you call deflection. Okay. If you want to show the values, you can go from here. Okay, so it will show you that these are the values for the shear force, these are the values for the bending moments, and it goes on. Okay. If you want to remove your shape or to hide it, you can hide it from it. So hiding the shape, showing it, Q is shear force, M is bending moment, W is the deflection. Deflection depends on the section, so you can identify it from here as well. Okay. Anyhow, as I told you, different options are there. Most of them are easy, so it does not require me to go and do, for example, a moment distribution method or slope deflection method to go and do it, or to do and calculate the bending moment and shear forces. Moment distribution method, slope deflection, these are easy methods, but they are time consuming in terms of reality later on, when you go to the work, nobody is going to give you the time to go and take, for example, 2 hours to solve pending moment uh, problem for a multi for a multi beam, for example, multi-span beam, where you can do it in 2 minutes in a software. Okay. So by learning the software, you will be having an extra edge against your other competitors, those graduates from the other colleges. So most of the colleges, they are not teaching the students the software. Whenever you add the software to your CV, it means that the person will try to or the person will trust you more, will trust that you have tried, and he will give you more opportunity to get the job. Okay, anyhow, we have finished from BeamAx. By finishing that, we have taken around 7 software. We have seen that we can model a beam getting the results for different types of loading within a maximum duration of 5 minutes. Okay, so if you can see, we have taken around 51 minutes with the explanation. So you can work it out for any of these software in lesser than 5 minutes for a beam. Okay. And whenever you what you call you get familiar with the software, you will not spend more than 2 minutes for working out a beam. Okay. By doing that, we have finished the first session. It's supposed to be around half an hour, but because of the number of software that they have added, it took us around 50 minutes. Uh, Initially, I was planning to have only 2, but I tried to give you as many as I can, so you can add them later on to your CV. It will increase your chances for getting a good job. Okay, so we are finishing session number 1. We go for a question and answer session for 5 minutes or 10 minutes, and then 5 minutes break, and then we'll carry out for second session, and then we'll go for third session. Second session and third session will not take much time since the number of software is lesser, and hope we are going to be finishing as soon as possible. So thank you very much for listening to the first session. Next time for question and answer.